So let's start with the new topic, that is unsupervised learning. Now, unsupervised learning is a type of machine learning algorithm used to draw inferences from datasets consisting of input data without labeled responses. Definition of this is that learning useful structure without labeled classes, optimization criteria, feedback signal, or any other information beyond the raw data. So you don't have any other idea except that the data that you have. What is the kind of output is again not known. Unsupervised learning is a class of machine learning techniques to find the patterns in data. The data given to unsupervised algorithm are not labeled, which means only the input variables are given with no corresponding output variables. In unsupervised learning, the algorithms are left to themselves to discover interesting structures in the data. Unsupervised learning is a term used for Hebbian learning, associated to learning without a teacher. That means you don't have a teacher to guide you, but still you have to learn. Also known as self-organization, and a method of modeling the probability density of inputs. Due to absence of the labels, one has to use clustering as a way of to find a solution to unsupervised learning. The cluster analysis is a branch of machine learning that groups the data that has not been labeled, classified, or categorized. Instead of responding to a feedback, cluster analysis identifies commonalities in the data and reacts based on the presence or absence of such commonalities in each new piece of data. Compared to supervised learning, where training data is labeled with the appropriate classification, models using unsupervised learning must learn relationships between elements of a data set and classify the raw data without help. This hunt for relationship can take many different algorithm forms, but all models have the same goal of mimicking human logic by searching for indirect hidden structures, patterns, or features to analyze the new data. Some of the most common algorithms used in unsupervised learnings include clustering, which has different types of clustering, that is hierarchical clustering, k-means clustering, mixture models, DB scan, optics algorithm. Then anomaly detection, local outlier factor, neural networks, autoencoders, deep belief nets, Hebbian learning, generative adversarial networks, and self-organizing maps. Let's try to understand clustering first. What does clustering mean? Clustering involves the grouping of similar objects into a set known as cluster. Objects in one cluster are likely to be different when compared to the objects grouped under another cluster. Now, clustering is one of the main tasks in exploratory data mining and is also a technique used in the statistical data analysis. While clustering is not one specific algorithm, it is a general task that can be solved by means of several algorithms. Some of the popular clustering methods that are used include hierarchical partitioning, density-based, and model-based. Now, another explanation says that clustering is the act of creating various clusters that have all objects under the data set. Further, clustering can be distinguished into hard and soft clustering. Under hard clustering, an object either belongs to a cluster or it does not belong, as you can see in the picture also. Now, however, with this soft clustering or fuzzy clustering means it is confusing. It's not, you are not very clear. An object can belong to many clusters. The ultimate aim of clustering is to intrinsically group unlabeled data. It finds applications in market research, pattern recognition, data mining and analysis, data compression, image recognition, and many more. Now, clustering or cluster analysis is the task of grouping a set of objects in such a way that objects in the same group called a cluster are more similar in some sense to each other than to those in the other groups or clusters. Its main task is exploratory data mining, a common technique for statistical data analysis used in many fields, including machine learning, pattern recognition, image analysis, information retrieval, bioinformatics, data compression, and computer graphics. Thus, in nutshell, we can say that clustering is divided data points into homogeneous classes or clusters. Points in the same group are similar as possible. Points in the different groups are dissimilar as possible. When a collection of objects is given, we put objects in the group based on a similarity. Now, application of clustering. Clustering is used in almost all the fields. It can be in your workplace, in a school, colleges, market, offices, residential areas, etc., etc. Thus, it is for the use to decide what kind of clustering he wants, and accordingly, the clusters can be created. Listed here are few applications that can bring more clarity. Clustering helps marketers improve their customer base and work on the target areas. It helps group people according to different criteria such as willingness, purchasing power, etc., etc., based on their similarity in many ways related to the product under consideration. Clustering helps in identification of groups of houses on the basis of their value, type of geography, geographical locations, etc. Clustering is used to study earthquake based on the areas hit by the earthquake in a region. Clustering can help analyze the next probable location where earthquake might occur. So this completes the first part of the unsupervised learning. Thank you.